Assalamu alaikum, my dear students. Now our next topic is that is about this multiple moments, right? Because if you talk about this, if you have a charge distribution within a given region of space, that is characterized by the net charge within the space plus that due to dipole moments and the quadrupole moments, right? Because we have, so we can have plus some higher order moments. Uh, in that system. So that means अगर हमारे पास system of charges हो गए, so that we can characterize it by the net charge within that system, right? Plus the due to the dipole moment and the quadrupole moments. So as you already know, if we talk about this quadrupole moment, that is simply you have two dipoles which are oriented in antiparallel direction, right? Okay. So if you write, if you expand now, if you expand now the potential in powers of this phi naught, phi 1 and phi 2. So these corresponds to, this first corresponds to our monopole term, and second corresponds to our dipole term, and third term corresponds to our quadrupole term, right? And so you are basically expressing this potential in powers of these monopole, dipole, and quadrupole terms, right? And this first term, that is our monopole term, so that's proportional to 1 by r naught, and this. Okay, so this monopole term, it is proportional to 1 by 1 naught. So this monopole term, and this is quadrupole term, and this is dipole, and this is quadrupole term, right? And you are basically expressing this potential in powers of 1 by r naught, right? So this is in one power also 1 by r naught, right? Now, so that means if we have enough number of these terms, so that means our phi n is proportional to 1 by r naught raised for n, right? Corresponds to different values of n for n equal to 0, 1, 2, 3. So this, it corresponds to all possible these terms due to this monopole, dipole, or quadrupole, or some higher moments also. So that means, so this is our, like if we talk about this quadrupole term, as I already told you, so it is basically if I have two dipoles which are oriented in antiparallel direction, right? So if you take the interaction of that quadrupole with that electric field, interaction of that quadrupole with electric field, that can be quantified in terms of this quadrupole moments. And similarly, we have dipole. If you take the interaction of that dipole with the electric field intensity, right, at some point, so that can be also quantified in terms of that quadrupole moments. So in general, these are all possible moments which are present within a given system of charge distribution, right? So we can rewrite this term as, so if you write this phi as, so phi can be written as, so that will be the first term, so that is, so this first term to the monopole, and similarly, and so let me expand this term because there may be some more terms, so that's why I put here some square bracket. So it is from this monopole, dipole, and this quadrupole term. So let's expand this. So instead of writing now, instead of, so if you write instead of, or if you write now, it tends to x. Okay, so we can expand them. That means we have this charge distribution. If you remember that, so we have that charge distribution in the system, and this is the origin of that charge distribution. And you are taking some point which is at a distance of RA, right? Right? Or, and you want to calculate this field at this point. Right? So you are saying that if this RA tends to x, you can then expand this term, that's RA minus x, you can expand this using that Taylor series expansion, or you can write this as instead of XA, you can write that R naught. Okay, it is R naught minus RA because this was that RA and this was R naught and this was R naught minus R. So RA के बदले अगर मैं यहाँ पे XA लिखूँगा, let's expand this. So this will be equal to that f of R naught first term minus that summation over A XA partial over partial X alpha. So this alpha here into 1 by. So what I did here is basically that because you are taking variation with respect to this XA, it is these are the components of that position vector R, and this capital X alpha, it is a these are the components of that R capital R. Right? So this is for small r this. That's why I write here that partial capital X. Right? And there's one more term that is, if you remember that 1 by 2 factorial summation over AB x a x b partial 2. Okay. Okay. So this is our that third term. So similarly, we have another one more term that's 1 by 3 factorial, and you can write this as, because this is partial 2 by partial x alpha partial x beta, because you are taking the distribution. So the different pointers within this system. So that's why I put here x alpha and x of beta, right? And 1 by r. Okay. Suppose this is our equation 8. Yeah. Now, in equation A, so there we have 6 terms, right? So out of 6, 1 will be 0, 5 will be non-zero here. Now, if you talk about now, let's apply this Laplace equation to this 1 by r now, right? So if I apply this Laplace equation to r, okay? So that will be equal to write that nabla square 1 by r naught. So that's equal to minus 4 by delta of r naught. So this r naught, if you remember that, this is the position of the point which is at a distance of r naught from this order, right? So this cannot be equal to 0, right? So r naught is non-zero. So that means I can write this as Laplace square 1 by r naught will be equal to, right? Or rest of that you can write this delta square of this will be equal to, right? So let us rewrite this equation. So if I rewrite this equation, so let us rewrite this equation, this term. Let's expand this term. So this term will be equal to, you can write this as, so phi 2 will be equal to, so that's 1 by 2 summation over. So there was few, so actually I forgot E also charge into the distance. Okay, and there's also that EX. Right, so charge into X. Okay. So let's expand this to phi 2 term. So this is phi naught, phi 1 and phi 2, right? Okay. So if you write now, what will be your phi 2 now? So that will be equal to summation over AB, or you can write E into XA XB, that is partial 2 by partial X alpha partial X beta into 1 by R. Okay. So this is our So this first term, second term will be, so from here we can have that one more term, that is 1 by 3 summation over r square delta AB partial 2 by. Okay, so where from this term comes? So this is, if you multiply by this, so this is 1 by 6, that's 1 by 3 factorial. So it is the another higher term that I'm taking here. So let's combine these two terms, right? And this r square, remember, it is basically you are getting that square of that x square, right? So instead of that, I can write r square, and this delta AB is nothing, that is our that partial x upon partial xb, right? So let us rewrite this term. So this term will be equal to summation over e. So this is inside. So we need to take this term outside now. So I can take this term common. So let us take this term common. तो यहाँ पे मुझे क्या लिखना है? I need to write that partial 2 by partial x alpha partial x beta 1 by. Okay. So यहाँ पे मैंने simply take this partial 2 partial x alpha partial x beta 1 by r naught common. The rest is inside within the brackets, right? Summation of e, right? Okay. So I can rewrite this term as so this term I can write as that's 1 by 2, or you can multiply this term by, okay, so you write that summation over e, and this is our d of e, right? E, okay, and partial 2 upon, so that means this d of ab equal to, that's equal to that xc xb 1 by 3 r square, right? And this DAV, this is our that quadruple movement of the system. So this is our quadruple. So you remember that because as a मैंने आपको already बताया कि we have this system of charge distribution that we can characterize it by the net charge, and we can have that monopole term. So that's purely a scalar. But if you talk about the quadruple, that's a vector. Now what about the, sorry, dipole? Dipole term is a vector. Now if you talk about this quadruple term, it's a second order tensor, right? It has 9 components, and we can prove that the diagonal elements of that quadruple, this tensor, that will be equal to 0. We can prove that, right? So that means if A equal to B, so that means the diagonal elements will be 0, right? So this is our that this term, it is coming from, this is the quadruple movement of the system, right? So if you want to calculate now this d of, if you put that dA equal to B here, right? So that means if you write now d of AB for A equal to B, right? So अगर हम A B के बदले लिखेंगे, so that means this will be equal to that XA into XA minus 1 by 3 R square, right? And there is so sorry, there is that d of AB is our this one. D of AB is, sorry, this is our D of AB. d of alpha. So this our d of AB is this one. Summation over E. This one. So there is summation over E also, right? So that is this one. This that Q2 will be equal to this. So this is 1 by 2 and phi 2 will be equal to. The d of AB is that summation over E x A x B minus 1 by 3. Right? And if you talk about now, so what will be this term then? So if you calculate, so this term should be equal to 0. So let us first calculate now. So before calculating that, the sum of the diagonal elements will be 0 in this second order tensor. So first let us calculate now. So this phi 2, let us rewrite this phi 2 first. So this phi 2 will be equal to, so that's equal to 1 by 2, or you can write that 1 by 6 d of AB, or you write that alpha beta also, partial 2 by partial x alpha, x beta, alpha beta. Okay, because you have to write that. So this is 1 by 2. So 1 by 2 into, okay, let me rewrite this term so it will be clear. So what I did here, because you can write now, so this all phi 2 will be equal to, so that's equal to 1 by 2 summation of E into, that's x A x B minus 1 by 3 r square delta AB, right, and partial 2. ये ठीक है, right? So मैंने इसको repeat किया, I am repeating this term, huh? So I can write this as, okay, so you can write this as, so this is 1 by 2 here, right? I simply multiply this by this, so this will be 1 by 6 this time, right? Or you can write this as, so 1 by 6, uh, this will be d of AB, or you write alpha beta here, because, or you write first AB, because we have AB here, so partial 2, right? Okay, so this is our phi 2 term, this is our product term, okay? Now we can do that, this d of alpha beta, or you can write AB alpha beta equal to d of that beta 1. So this is symmetry. And let us calculate now, if we have this A I equal to 0, if we want to calculate the diagonal elements. So that means if you put that alpha equal to beta, what is d alpha alpha? Let's calculate that if alpha equal to beta. So that will be equal to summation over E into, that is 3 x A x a, or you write this alpha alpha. Okay, you write that a equal to b because a equal to b. So that is equal to a. Okay, so because यहाँ पे मैंने a भी use किया है, so this is 3a x a right minus r square delta a. So this term will be equal to what? This conical delta and this is r square, right? Okay. Okay. And this term will be 3r square, 3x square. You can write this is equal to, so this will be equal to 0. Because if you remember that, this can be written as, this can be written as, this can be written as 3x square, right? Or this is 1 by 3. So this will be 3x square minus 3x square, right? So this will be equal to 0, right? So this is 0. So that means diagonal elements in this quadrupole, this second order tensor, so those all will be 0, right? Now if you talk about in three-dimensional space, now in 3D space, right? So we can write that this R naught. So R naught I can write as, that is, okay. So I can write this as, and summation over I. You can write this as summation over I. Okay. Now so that is because we need to evaluate this term. तो हमें ये term evaluate करनी है, right? So that means at first यहाँ पे मैंने I need to write this R not in terms of that x y z, or you can write x I square because I takes values 1 to 3. Okay. Now if you expand this, now if you expand this term, because we need to expand this term, right? So we need to expand that partial to. So ये term हमें expand करनी है, right? This term. So that means first I will differentiate this with respect to beta, this 1 by R naught, and then with respect to alpha, right? So first let's write now. So that's partial upon 1. Okay. Or you can write this as, because the rest of that 1 by R naught. So this will be equal to x I square raised per minus 1, because you need to take 1 by R naught. Huh? So this clear. So let us differentiate it with respect to that x of beta. So first term will be, so this will be minus 1 by 2. Now you differentiate this one. So this will be equal to, okay. So this is clear because first to differentiate this minus 1 by 2 partial x I raised per minus 3 by 2. And differentiate this term, that is twice xi, now xi with respect to this beta, okay? Or this is equal to, so 2 will cancel here, minus, Okay, right, because this term will be that I beta, because अगर I beta के बराबर होगा that is partial x by partial x, right? Because we don't know whether it is with respect to beta, if beta equal to I, so we can write this derivative in terms of that delta function. So this will be delta I. Right. Now if you put now, so this is our summation over I. Okay. Now you put I equal to b, right? So this will be equal to, okay, right? And this term will be equal to 1, so this will be, okay. So this is our that partial upon x of beta 1 by r. So this is, but the whole term is that is partial to by partial x and by partial x beta, right? So first term हमने evaluate की. Now you need to differentiate this term with respect to partial x alpha, right? With respect to this x alpha. So if I write this as, so this will be that partial by partial x alpha, inside will be minus, okay. So let us differentiate this term. So first, so let us rewrite this term. So this will be equal to, you write this as, first differentiate this, then this. So let us differentiate first term. That is partial upon partial x alpha, and okay, you write this as x beta constant, and you take this as, right. And second term will be, okay. Sorry. So this alpha here. Huh? This alpha is this alpha. So let's first evaluate this term. So here this will be minus 3 by 2. You can add that x beta minus, it is plus 3 by 2 summation I square, okay, raised power minus 5 by 2, right, and this will be that uh, this will be twice summation over I xi partial xi partial x, right. So मैंने क्या किया, first when you differentiate this minus 3 by 2 partial summation over I xi square raised power minus 5 by 2. So let's now differentiate this term. So this is twice xi, then partial xi by partial x and x beta is multiplied. So this is our first term, right? And second term is that is minus. So this is that summation over I, right? So this is as it is because partial x beta by partial x. So let's rewrite this term. Okay, so first one will be, so this is our phi 2. So that's equal to, so this will be here 3 will cancel, 2 will cancel with this one because this 3 by 2 is 3, so 2 will cancel, and I will get here that summation over I, that is 3x beta, okay, and inside will be summation over xi square raised power minus 5 by 2, and now xy, and this term will be delta of I alpha, right? Because this is partial xi by partial x alpha, so this is delta I alpha. Because when I equal to alpha, so ये बन जाएगा partial x by partial x, right? Like that. Because I takes values those 1 to 3, okay. And second term is, that is minus, because so ये term ऐसे रहे मैंने रखी यहाँ पे, and इसके बदले मैंने लिखा that is delta alpha beta, right? So this will be equal to 1 when alpha equal to beta. Okay, so so instead of this, if we write now, because we have that R naught, if you remember that R naught is basically the distance of that distance of point P from the orbit, right? So right, so while you want to calculate the electric field, right? So you are taking the this interaction of that system of charges which contains those monopole terms, this dipole and quadrupole terms, or even higher order moments, right? Interaction of those terms with that this electric field intensity at some distance or not, right? Okay, so that basically gives us these moments, because you are saying that how this dipole or quadrupole moment interacts with that external electric field, so that you can quantify in terms of that these multiple moments. I mean to say that monopole moment, dipole, or you can say quadrupole moments, right? So let's write down, because R naught, if you remember that, so that's our that xi square is for 1 by, right? So if you want to calculate now, because we can write this as to write that R naught square will be equal to xi square, xi square, right? Or you can write that xi will be equal to R naught, or if you write that what's our xi R naught square, right? So I can write this as, so instead of this term I can use this as, because our phi 2 is here, so you write that, because so instead of this R naught xi square you can write this one, so this will be equal to that 3 x beta, okay, and this is that summation over I xi is for minus 5, okay, and xi, and then I equal to alpha, so this is equal to 1, right? So we can write this as, okay, you write that first to delta I. Let me rewrite the whole term, then we can write it. Minus summation over I xi cube minus 3, and this alpha equal to alpha. Now first term में मैं क्या करूँगा, if I put this I equal to alpha in first term, and in second term I put alpha equal to beta, right? So first term will be that's 3x beta summation over alpha, so this will be equal to that x alpha raised power 4, sorry, raised power 5, raised power minus 4, right? And minus that is summation over that I xi raised power minus 3 delta alpha. Now, if you again choose that alpha equal to beta, so this will be equal to that is 3 xi raised power minus 3, sorry, x raised power that beta raised power minus 3. Okay, right. So this will be equal to, this is 3 x alpha 3 by, I think I should stop here because I can continue from this onwards maybe tomorrow.